Concrete is the primary building component of our developed world. With it, the human race has built buildings, cities, bridges, ports, marine walls and piers, caisson infrastructure, tunnels, sewers, dams, highways and roads, rail transport, and the very homes we all live in. Concrete is made from sand, coarse aggregate, cement, and water. When placed or cast in its freshly mixed form, bleed water in concrete escapes to the surface and evaporates, creating capillaries. These microscopic arteries go deep into the concrete matrix and can stay open permanently after bleed water escapes to the surface. These open capillaries make concrete vulnerable and expose it to attack in many forms. The principal avenue for attack is moisture, which can lead to problems such as corrosion of the embedded reinforcing steel. For corrosion to occur, you need three elements: a metal that can corrode, oxygen, and water, the last two of which get into the concrete through these open capillaries. Another problem is cracking, caused by mechanisms such as plastic shrinkage, moisture and thermal gradients, and freeze-thaw processes. Moisture level changes in the capillaries and pores, along with temperature changes, cause the concrete to expand and contract, which can result in curling, warping, and cracking. Efflorescence is the result of internal moisture migration that transports the concrete's soluble alkali hydroxides to the surface and then evaporates. Not only does this leave voids in the concrete for more moisture to enter, but it also leaves a highly alkaline deposit on the concrete surface, which is known to attack cladding, coating, and flooring systems. Moisture leaving the concrete creates other flooring problems, such as mold development and adhesive failures. Water, the very element that gives concrete its life, can also destroy it if the concrete is not protected. Traditional attempts to solve this problem have included crack-filling compounds, surface membranes, coatings, silanes and siloxanes, and silicates. Unfortunately, these options are temporary and therefore inadequate. They add additional costs over the surface life of the concrete while only treating the surface, leaving the real problems to fester within the concrete. Ultimately, none of these methods are permanent solutions to the problem. There is a solution, however, and it's called Spray Lock Concrete Protection, or SCP. SCP penetrates deep into the accessible capillary pore structure, reacting with available free alkali, filling and sealing them with a stable gel structure. It shields the concrete from most forms of external and internal attacks for the service life of the concrete. SCP has an amazingly unique ability to transform standard concrete into what the American Concrete Institute defines as high-performance concrete. Because it's non-toxic, SCP may be used on any conventional or unconventional concrete application. It contains zero volatile organic compounds, so it may be easily incorporated into LEED or sustainable design projects. Unlike other surface-applied treatments that have to be reapplied every 1 to 5 years over the surface life of the concrete, SCP only needs to be applied once to new or existing concrete to provide long-term protection. Shouldn't the things we build last for a lifetime? Incredibly, protecting concrete is not all SCP achieves. There are numerous benefits available when applied to newly poured or old existing concrete. When used at time of concrete pour, SCP provides the curing benefits of water ponding without the associated delays that can normally extend to months. This time-saving benefit accelerates construction time, providing a significant savings in time and money to every project. Installers from across the globe have installed new flooring on newly placed concrete treated with SCP in as little as 14 days after pour, which would have normally taken weeks or months for the concrete to be ready for flooring installation. SCP also is uniquely able to strengthen and densify concrete, as it enhances the concrete's hydration process. It helps create more calcium silicate hydrate within the capillaries and pores of concrete, which can also enhance the hydration of cement particles deep within the concrete. By filling rather than just blocking the capillaries, this process has been shown to increase compressive strength by up to 20%. Independent testing of SCP shows up to a 50% reduction in concrete surface abrasion. And there is up to a 97% reduction in carbonation penetration. At time of placement, curing with SCP fills accessible capillaries and pores and seals in valuable moisture needed for concrete hydration. Since this process reduces shrinkage by up to 91%, volume change distresses such as curling, warping, and shrinkage cracking are greatly reduced. Independent testing has even shown that SCP-treated concrete is more resistant to freeze-thaw damage than air-entrained concrete. All forms of Portland cement concrete can be treated at one time on horizontal, vertical, or overhead concrete surfaces. Treatment with SCP from either negative or positive pressure surfaces can ensure that underground tunnels, walls, tanks, and pipelines are protected against moisture-related damage. SCP has been used on walls where up to 100 meters of head pressure exists on the opposite side. Laboratory testing has shown up to 100% reduction in water permeability, depending on the concrete condition. This internationally accepted test puts concrete under high pressure for 3 days to test resistance to water intrusion. SCP was applied to the sample on the right, and you can see the very limited penetration by the size of the penny on it. SCP also provides enhanced resistance from salt attack in marine environments, as the salt can no longer penetrate into the capillaries. This includes the residual chloride ions from desalinated seawater that can destroy drinking water storage tanks by accelerating the onset of rebar corrosion. In relation to acid protection, these pictures show 2 concrete sample blocks made from the same concrete batch. One treated with SCP, the other untreated. Both were immersed in a strong and torturous hydrochloric acid solution. These are the results after 1 hour. These are the results after 2 hours. The results speak for themselves. With SCP, the service lives of concrete infrastructure can be greatly extended with an increased strength and durability that untreated concrete cannot match economically. SCP has been used for over 30 years to protect concrete infrastructure. We also proudly offer the longest warranty against moisture migration through the concrete in the industry. Concrete, in one form or another, has been with us since the dawn of civilization. Yet we have huge companies producing temporary single-purpose products to address concrete protection. Why not prevent tomorrow's problems today? Inspired by the spirit of innovation, our vision is that concrete should have a one-time treatment that permanently reduces the maintenance needed during its service life. With our unique solution, now concrete does. For more detailed information, visit us at www.spraylockcp.com.